When we talk about increasing and decreasing functions, what we're talking about is the gradient. So this function is increasing here because the gradient's positive, and it is also increasing here because the gradient is positive. Then it's decreasing here, and the gradient is negative, and we also have stationary points here and here where the gradient's equal to 0. Okay, so either we can have f dashed of x greater than 0, that means that it's increasing, or if f dashed of x is less than 0, that means it's decreasing, or if f dashed of x is equal to 0, then we have a stationary point. So basically we're talking about the gradient with all of these, and we're seeing whether it's positive, negative, or equal to 0. Here are some examples. Right, so first one, we want to find where this function is increasing. So x cubed plus 6x squared minus 15x plus 8. So the first thing we do is differentiate to find f dashed of x. So we get 3x squared plus 12x minus 15. And we want to find out where it's increasing, so where that's bigger than 0. So I'll just write here, increasing. So first let's divide through by 3. So we've got x squared plus 4x, take 5 is greater than 0. And now we can factorise x plus 5, x minus 1, greater than 0. And it's a quadratic inequality, so we need to draw the graph. So that's going to be minus 5, this is 1. And because we're looking for where this graph is bigger than 0, we want where it's above the x-axis, so it's this bit and this bit, and so we write x is less than minus 5, or x is bigger than 1. Okay, now let's do a decreasing example. So we want to find where the gradient is negative of this function f of x. So our function is x squared take away 2, multiplied by 2x take 1. And before we can differentiate, we need to expand these brackets. So we don't know yet how to differentiate things in this form, so we have to expand. And we get 2x cubed minus x squared minus 4x plus 2. And so now we need to differentiate. F dashed of x is equal to 6x squared minus 2x minus 4. And we want to find out where that is less than 0. So that's where 3x squared take away x. So we're dividing by 2 here. Take away x, take away 2 is less than 0. We factorise 3x, x, less than 0, 2, 1, plus, minus. Okay, and again, quadratic inequality. Draw the graph. So we've got 1, and we've got minus 2 over 3. And we want where this graph is less than 0, so where it's below the x-axis, which is here. So our solution is where x is between minus 2/3 and 1. Last one, we now have f of x is x to the half minus 2x, and we want to find the stationary point. So we want to find where the gradient is equal to 0. So whatever the graph looks like, we want to find out where it's flat, where its gradient is 0. So first we differentiate to find the gradient function. So we get half x to the minus half minus 2 equals 0. And so then we can say that a half x to the minus a half equals 2. X to the minus a half is 4, multiplying both sides by 2. Now we can write that as 1 over root x equals 4. And if we multiply both sides by root x and divide both sides by 4, then we can say that root x equals 1 over 4. And then finally that leaves us to x being 1 over 16, squaring both sides.